Jason, we're going to start.
Ready whenever you are. Hang on.
Good day. My name is Dr. Leon Perlman. I want to welcome you to the Columbia Business School DFS Observatory webinar. We've got a superb crowd today from around the world. Our topic is Introduction to Bitcoin, Blockchain, and Distributed Ledger Technologies, and its application to financial inclusion. The webinar will last about 45 minutes to 50 minutes, and there'll be 15 minutes of Q&A after the presentation. We'll have a quick poll, and after the presentation, there'll be an optional live quiz of about 10 multiple choice questions. The link will be sent to you shortly, and you'll also look out for the link to the quiz in your email, and especially check your spam folder. The link is live for 2 hours for certificate purposes. You can earn the webinar certificate. And after 2 hours, if you take the quiz, it won't count for certificate purposes. So just a bit about the DFS Observatory. It's a Gates-funded initiative at Columbia University, housed within CITI at Columbia Business School. You can go to our website, dfsobservatory.com, and you can see some of our activities. We have a massive legal and regulatory database on digital financial services, model laws and regulations, annual DFS and Emerging Payment Summit, which we had back in June, webinars, roundtables, publications, commentaries and analysis, and close cooperation with industry, regulators, academics, and SSPs around the world. These are the range of webinars and events. If you go to the website and look under archive, you can see recordings of previous webinars and our annual DFS and Emerging Payments Conference. So as I mentioned, you can earn a certificate of attendance. You need to attend 6 webinars and get 60% for each of the webinars that you attend. You're going to have to concentrate on the content to complete the quiz, because the slides aren't available afterwards. So all the answers to the quiz will be within the webinar, so on the slides and in audio. So please look attentively. So on to the webinar. It's a important and emerging topic, Bitcoin, blockchain, and distributed ledger technologies. If you're in the fintech world, in the DFS world, it's a term of art that's being used by industry and regulators quite often. So we thought that there was a need to ventilate and explore the issues around it. So this is a primer or an introduction to the technology. It's not complex. There's no complex mathematical formula in it, although blockchain is a whole lot of cryptographic stuff. So we're trying to make it as high level as possible. So you'll see as we go along, concepts are explained in words and graphics in as simple terms as possible for the audience. So it can get complex, as this cartoon shows. But again, we're going to make it as high level as possible. So what's the problem we're trying to solve here? It's a global challenge, how to access and store growing amounts of data securely, faster, cheaper, and for the benefit of all. what's the data? Well, assets, anything really, assets, property, voting, identity, financial data, contracts, digital rights, payment and settlement information, and a whole lot of others as we'll see as we go along. So right now, the way data is stored and accessed is usually in silos and centralized. So there's usually somebody or an entity in the middle that stores the data. You can imagine some sort of database that has your payment information, your ID information, or whatever. And as we'll see, this becomes very inefficient. So the data is in silos. So a tax authority will have one set of data, the bank, the auditor records, you yourself will have the data, and these are usually insecurely and consistently stored in multiple databases and easily hackable, as we've seen from recent headlines. And even in some cases, we come across the data is stored in paper records. Clearly, something needs to be done to make it more efficient. So it's a global challenge because the data is centralized in silos. It's a single point of failure, stored in often incompatible systems, often out of date, vulnerable to hacking, inconsistent formats, inefficient, expensive to run multiple data, error sensitive. If somebody inputs data incorrectly, then it has downstream effect on everybody. And of course, it's in paper form, which is really a no-go. So the solution that has evolved is something called blockchain technology. And we'll see how this all fits together terminology-wise, Bitcoin, blockchain, distributed ledger technology. So really for blockchain technology, you take the centralized data in silos and you share it. It's as simple as that. So you decentralize the data, you distribute or share the data. So you take that centralized ledger, which on the left, which you saw earlier, and you distribute it. So everybody has access to the same data in almost real time, and it's extremely secure. So all the data is linked efficiently and uniformly and securely on what's termed a blockchain ledger. So you can see that overall shape, everybody is now connected to each other instead of sitting in little silos where the data needs to be placed on separate databases. So where did this blockchain idea come from? Well, it evolved from somebody who called themselves Satoshi Nakamoto. We don't really know if Satoshi Nakamoto is a real person. It's an endless debate since 2008 when this paper that introduced a concept called Bitcoin appeared, a peer-to-peer electronic cash system. So what did Mr. Nakamoto's paper talk about? Well, it spoke about Bitcoins and blockchains. So very simply on the left, blockchain is a technology, and on the right, Bitcoin is a cryptocurrency that he introduced. That's a way of buying and selling things with value. So the blockchain, the technology, is also known now as distributed ledgers, also known as shared ledgers, but the term that's in use is distributed ledger technology, but some people call it shared ledger technology. Terms of art that you'll come across are mining, it's secure, consensus, and it's now used for more than just the cryptocurrency, the original one. Bitcoin's gone far beyond that, and each of the transactions that underline a transaction is stored in what's called a block. So on the right-hand side, Bitcoin, it's decentralized, so there's no central issue of this currency. It's powered by this blockchain technology, so everybody has visibility of it. You can buy and sell, as I said, goods and services using Bitcoin currency. You need to buy it using fiat currency like a dollar or a peso. And it's pseudo-anonymous, so the users mine these Bitcoins, and there's a maximum of 21 million Bitcoins that can be issued. But since then, since 2008, there are lots of other cryptocurrency types or Bitcoin types. These are called altcoins as a general name. So the way mining works, you can imagine that go back a century or two, somebody is walking along a stream and they see a gold nugget and they pick it up and, wow, they've got a gold nugget. So they pick up all the gold nuggets on the surface and now they want more and there's nothing on the surface, so they need to buy a shovel. Buy a shovel, get all the gold nuggets that are shoveled in, and those are depleted, and then buy something bigger to mine even further. And as you can see, you need more complex equipment to mine. So with this 21 million Bitcoins, the first couple of Bitcoins were easy to mine. Those are the surface gold nuggets that you just pick up. And as the algorithm which underlines the Bitcoin blockchain, it's a puzzle really, needs to be solved. You need higher computing power to solve the complex problems. So it uses up a lot of electricity to mine these Bitcoins currently. And as you'll see, there's a change afoot to make this slightly easier. So as far as Bitcoin goes, in June 2010, a Bitcoin costs you 6 US cents. So 1,000 Bitcoins would have cost you $60. And now, I just checked the Bitcoin price before we went online. The Bitcoin price is hovering, that's 1 Bitcoin, hovering around $2,764. So 1,000 Bitcoins, if you'd invested $60, would be almost 2.8 million US dollars, which is quite a return on investment. There's some people which believe that it's going to go to a few $1,000s. Some people even believe it's going to go up to $500,000 per Bitcoin, but we'll see. As I said, the electricity to computing power that's required to mine these Bitcoins is very expensive. There's a lot required. So there's an idea to split the Bitcoin blockchain, commonly called forking, and split the Bitcoin blockchains to 2 different types, ostensibly to improve transaction processing times and also to improve mining times. So 2 fork types have been proposed by the community, and it's a very amorphous community because there's no central issuer. So those who have the majority of Bitcoins or the hash power, those can call the shots. So the 2 fork types that are proposed, kind of fork is a split, user-activated hard fork, UAHF, or user-activated soft fork, UASF. The technical details are a bit beyond the scope of this webinar, but it's coming up ostensibly on August the 1st and has implications for value storage. So if you have Bitcoins, you might or not be able to still use them. It all depends on what happens on August the 1st and beyond. As I said, there's a lot more cryptocurrencies now in use, giving it the general name cryptocurrencies. They're called other things, altcoins. And this is a snapshot today of the market capitalization of the cryptocurrency. So you can see on the top left, the 821 currencies currently in use. Bitcoin is the biggest with what looks like a market capitalization of $45 billion. Then there's another one called Ethereum. Then there's Ripple, which is not really blockchain, but it's a cryptocurrency nonetheless. Litecoin, and if you go to that list online, you'll see there's those 821. So this is growing every day almost. As soon as you've got a new algorithm and you create a new cryptocurrency and you go sell it on these exchanges. So technology hierarchy. As I said, we've used a lot of terminology. Distributed ledger technology, also known as shared ledger technology. Then the B in blue for blockchain and Bitcoin. So where we are is that distributed ledger technology is the overall term. That's the hierarchy. Within that, you have blockchain, which is a type of distributed ledger technology. There are others like Ripple, which is not blockchain. So blockchain we're going to use as a proxy today for distributed ledger technologies. But just keep in mind that there are other DLTs. And Bitcoin there at the bottom with that B and the $ looking thing sits under Bitcoin. So at the top, you've got distributed ledger technology, then blockchain, then Bitcoin as an application of the blockchain technology. So core concepts, which you'll find in the blockchain lexicon, it's a distributed ledger. So the data is stored, as I said, in blocks or sequential blocks. It's secured through cryptographic keys. You need a private key and a public key to add data to it. It's tamper evident, so you can check whether or not the data has been tampered with at any stage. It used to be termed immutable, but there was an incident where immutability was proven incorrect. Immutability means you can't go backwards. So what we're left with now is tamper evident. We can see if somebody's actually tried to hack the blockchain with all the secure data on it. And what's important here in the distributed environment is that because you don't have a central party which controls the data, what you use instead is something called consensus, where everybody on the blockchain has to say yay or nay to add more data. So if you want to add a financial transaction, everybody on the blockchain has to say, yes, this transaction data is okay. We don't know if it's true, but the block size and the transaction data within the block is okay. So yes, we like it, add it, please. So that's a brand new concept in DLT is consensus. So just to put it in all perspective, the terminology, we've got replicated databases, and all those dots in that image on the right-hand side, those are called nodes. So those are the people that would say yay or no to the consensus. And the data is on the blocks, and all the nodes have a copy of the blocks on the blockchain. So it's disaster-proof. If one node fails, lots of others to take over. So since Nakamoto's paper in 2008, blockchain technology has, of course, evolved for various applications, and we've got lots and lots of these types of blockchains. So it's now permissioned or permissionless. Permissioned simply means you need permission to add data. Permissionless means you don't. It can be public or private. So in the financial world, most of the blockchains are private. So you can't see anybody else's financial data unless you're given consent. And you get combinations of the above. So as an example, Bitcoin is permissionless and public versus the financial transaction blockchains, which are mostly, for seemingly obvious reasons, are permissioned and private. So this is how it all works. As I said, the blocks are, the transaction info is stored on the blocks. New data inputs from participants, the nodes, are usually as a result of the mining we spoke about earlier. Lots of processing power required. As more data in the new blocks is added, the chain grows. So that bit on the right-hand side in yellow needs to be added, and there's a whole lot of stuff that needs to happen. Somebody tries to alter any of this, it's everybody in all the nodes on the blockchain will be immediately notified that somebody is trying to hack it. So as I said, it's also secured via cryptography, these private and public keys. So the signing with the keys serves multiple purposes. The nodes must sign to confirm additions to the blocks. That's the consensus paradigm we spoke about. It also confirms the identity of the parties, and also encrypts or hashes, as is also known, the data on the blockchain. So it's very secure. It's very, very difficult to break the encryption for now. Again, it's tamper evident. So insofar as the security, you know, you're going to have a blockchain that sits here in 2017. Who knows what the computing power in 20 years' time will be. So some blockchains might need to be updated with new secure mechanisms, new secure algorithms as computing power to crack security increases, and we all know over the years that's happened. So these blockchains need to be designed to anticipate any increases in computing power that could ostensibly break the keys, but we're not there yet. So the consensus. If a participant wants to add new or mine data in a new block, the majority of the nodes need to okay its addition. So that yellow bit on the right, everybody has to go like multiple times over many nodes there on the blockchain. And very simply, no consensus means no addition of the proposed new block. So it never gets added. So how does this all fit together? So let's start on the top left. At start, a node wants to add data to the blockchain, so they do a request to add a new block, and that's broadcast to all the nodes on that particular blockchain. The nodes check the new data, say yay or nay, like. They use their digital keys to do that, and they verify the data and agree to add the new data. That's at the bottom right. They then broadcast their consensus to the general blockchain, and at a certain point, the new block is added to the blockchain and completed. And the cycle then begins again. The blockchain awaits a new block request, and this can happen all the time and does. Just to say that blockchains are not necessarily interoperable. So you won't necessarily have a bank-driven blockchain with financial data talking to a blockchain that works on digital rights management for music. There needs to be some sort of bridge, and this is still work in progress in the blockchain community. There are lots of ideas on this, and there are some interoperability initiatives going, but generally speaking, they're not yet interoperable. Another feature I'd like to highlight about blockchain is this new concept called smart contracts. So these very simply are self-executing contracts using the if this happens, then that should happen paradigm. And the primary blockchain technology, again, we've got lots of blockchain technology. Bitcoin is one blockchain technology. Another one very popular is Ethereum. Ethereum blockchain technology has a smart contract paradigm built into it. Bitcoin doesn't have, in its current incarnation, doesn't support smart contracts. So here's how it works. You in plain language, go to the script. It's a computer application, and you type in something or other to do with a set of events. So let's go to one. On the left-hand side, if the agreed amount is received on time, this is for selling something. Then, and that's number 2, then designate the buyer as the new website admin and pay the seller. So this happens all automatically. This, depending on the jurisdiction, is can amount to a legal contract. It doesn't mean you don't need a lawyer. A lot of people confuse the two. Because it's a smart contract, you don't need lawyers. I would advise against that. These things are very complex, and because they're self-executing, they're almost like nuclear fission. Once you press the button, that's it. It's a chain reaction, and you can't stop it. So you've got to be very, very careful in terms of what you put into the smart contract, because it does have real-world consequences. Last year with Ethereum, there were some issues around the smart contract where there were bugs, and it was hacked, and it caused a whole lot of problems for those using the Ethereum blockchain. So I think people have learned their lesson and create these smart contracts very wisely with legal assistance. Doesn't mean you always need a lawyer, because some of these things can be very simple, but it's advisable too. So the point I try to make here is that smart contracts doesn't mean no lawyer. It just means that you can do it yourself and have somebody check it. Another concept which is gaining in popularity is something called ICO. Initial coin offering. So it's a new unregulated method for startups and others to raise capital using new, mainly blockchain-based cryptocurrencies. It's like an initial public offering, but the salient difference here is it bypasses traditional exchanges, venture capitalists, and brokers. It's also called an initial public coin offering, or IPCO, or crowd sale. And in this case, instead of selling shares, you share the terminology that we use in the ICO blockchain world is called tokens. So shares equals tokens, and almost like an IPO, a percentage of the new cryptocurrency token pool is sold to early backers of the project in exchange for legal tender or other cryptocurrencies. So you can buy into this through exchanges using real money, fiat money, or you can just send them bitcoins and you get a percentage of the ICO. And this has become extremely popular, and there's a new one every other day, and a very popular way of raising capital. So again, some selected blockchain initiatives. The big one really is the R3 Consortium. It's headquartered here in New York, where we are. It's backed by 70 banks and insurance companies for settlement and trading blockchain activities, and trades digital assets on the private blockchain network. NASDAQ, again here in New York, is using a blockchain to record private securities transactions for the first time. even has a VP acting as its blockchain technology evangelist. Australian Stock Exchange is developing a private blockchain with US-based digital asset for post-trade equity settlement. Estonia is using blockchain for share issuance and voting. There are lots and lots and lots of these initiatives. We could go on for entire day describing all of them, but I encourage you to look it up on the internet. One of the main technology evangelists relating to blockchain is, believe it or not, Richard Branson. You can see him there jumping into his pool in his private island in the Virgin Islands. Now, the people you see around him are part of his very exclusive blockchain summit, which he has every year. In fact, he just had one last week. And they all get together and come up with some brilliant ideas on how blockchain should be developed around the world. I think it's a couple of days of the summit. We'll see what comes out from the reporting of what was decided. In fact, some very interesting stuff has come out of the last couple of summits. So looking forward to seeing what comes out from this summit. So Richard Branson is main guy in blockchain world, believe it or not. He's everywhere. Now, onto the financial inclusion applications of DLT and blockchain technology. So a lot of these are in taste, and a lot of these are stylistic, and a lot of these are combinations of the art. So let's use our smart contract example to describe microinsurance for small farmers. So on the left, you have your small farmer. He's buying drought insurance. And the smart contract very simply says, if there's a drought, then pay the farmer automatically. Doesn't need to send in any forms. Doesn't need to wait for anything. It's all done automatically through the smart contract. So there is technology that uses mobile base stations to check microclimates to see if there's moisture or rain. It's called attenuation, and this would be linked to the blockchain. So these mobile base stations would say there hasn't been any rain, therefore there's a drought. So that triggers the smart contract terms which say if there's drought, then pay farmer. And then there's automatic payouts from the insurance company to the farmer, and very simply the farmer gets notification on their phone, and it credits their mobile money or bank account. And as simple as that. And that, to some degree, is in place. The blockchain applications are being tested, but that paradigm of microinsurance and automatic payments is already happening. Again, using our initial coin offering for small farmers, this is happening in some respects. So on the left, let's just say the farmer wants to buy a tractor or build a new barn. They, maybe with some help, go to a dashboard and create the ICO. So ICO, really what you need to do is create your own, and I'll use this very broadly, your own cryptocurrency, your own coin. So that's what you're selling. You're selling a coin, a colored coin of sorts. And that's what people buy. Instead of a share, your coin is your token, and that's what people are buying. So now you broadcast the fact that you've done all this and tell people to buy this. And all this stuff is sitting on an exchange. People come along to the exchange and use fiat currency, US dollar or Bitcoin, to buy these tokens. They execute a smart contract to say, I'm now a shareholder, and if for some reason we don't reach the required amount of interest in the ICO, then your money will be returned. So that's all in the smart contract. Let's just say it's all good. The ICO is successful. The threshold of capital is reached. The farmer gets the money and can buy the tractor and the barn. Very simple. And that's how you raise money with an ICO. Again, go check it out online. There's lots of these things happening, and it's a new way of raising capital without having to go to a VC or brokerage firm or any other formal environment. One thing I will say is that to a large extent this is risky, is because it's unregulated. Another application in the wild is remittances via Bitcoin. There are lots of companies doing this, but I wanted to highlight a company called BitPesa because they were one of the first. They send value via the Bitcoin rails versus banks, SWIFT, Western Union, etc. And they operating in Nigeria and Tanzania and one or two other countries. They ostensibly were operating in Kenya until they had a court case with Safaricom, which runs M-Pesa. So that market is there, but not as big as it could be because of the court case. In fact, the Kenyan Central Bank has got a negative view of Bitcoin anyway, which is, we'll see, is the view of stance of quite a few central banks. So remittances via Bitcoin, that's also one solution to de-risking, which has been proposed and in place. De-risking, of course, is where a company is shut off from formal remittance corridors through SWIFT or the like because of concerns about money laundering or some similar regulatory issue. So something else which is happening in the wider world, but let's bring it down to the financial inclusion world, is interoperability and settlement between parties. So right now on the left, the current clearing and settlement style is through a central counterparty, also running a switch of sorts. So all those parties on the left would have to connect to the switch and pay switching fees, and the central counterparty, if attacked, it's a problem. So there's risk, there's fees, and there's lots of other governance issues. Whereas the solution on the right is blockchain-based, and what you have, which is quite nice, is a real-time liquidity check, and it's cheaper and faster. So in terms of the real-time liquidity check, in a clearing and settlement environment where you're going to pay somebody after you both send each other instructions to pay, you get what's called netting, and then somebody owes somebody money at the end of the day. But you need to know that that person is good for paying you at the end of the day once all the transactions have been netted. And you don't really know that unless they give a guarantee of sorts. And guarantees cost money because it removes capital, working capital. So there needs to be a better solution, and that's through the real-time liquidity check using blockchain. So very simply, what happens is that the party who's paying gives the party who it's going to be paying to a window, a very limited window to check whether or not that party, the paying party, has got enough liquidity to pay. And that's done in real time. So instead of seeing all its financial books, it just says, just check if I've got enough money and we can go ahead. So that's done in real time and constantly, and you can only do that through blockchain technology. So that's being done through other consortia, and some people are trying to apply this to the financial inclusion world. Identities on the blockchain is another aspect which is got a lot of attention, simply because in a lot of jurisdictions there aren't identities. So you've got a greenfield way of building identities, which is secure, it's not paper, so you can't tear it up. I think the best example, which is not blockchain but of digital identities, is the Aadhaar system in India, which has digitized identities through biometrics. So you can do almost the same with blockchain, and use facial recognition or fingerprints or iris scans and store that. So somebody can transport those identities and attest to the fact that it was created in a secure environment, and therefore it's good to go for any application that requires a verified identity. BankQ is doing this in a number of places, Latin America and Kenya. They're one of the first to apply this. There are quite a few others that are since come along. But this is the new way of, new idea to store digital identities where there's actually no consistent and secure identity system in the country. Another interesting application of blockchain is what's called digital fiat currencies. So as an example, the Barbados central bank is proposing to create a blockchain-based digital dollar in conjunction with service provider BIT, which operates in the Caribbean. So the plan is to implement an interoperable digital fiat currency throughout the Caribbean, not only with the save on cash, but it would then also be interoperable. But as importantly, in the mobile money, digital financial services realm, you will no longer need to first convert fiat currency or value to electronic money for use in mobile money systems. The pool of funds is already e-money or digital fiat currency as e-money. So that conversion doesn't need to take place, which increases efficiencies and decreases costs, because there is a cost to conversions. You need to have multiple bank accounts and multiple accounts. It's looking promising. We'll see where this initiative goes. I think they're making some announcements even this week. Another initiative is Bitland in Ghana to put property, this is not the only one, by the way, there are lots of others, to put property registrations on blockchain, so that apparently there's a big problem that people just assume the title of some land or property and nobody can contradict them because the records are not available, lost, or incorrect. So the idea now is to regularize this by putting all those land title registries onto a blockchain. So now let's come to some other open issues, or the legal and regulatory issues in blockchain technologies. So let's just differentiate between Bitcoin regulation versus blockchain regulation. They're often thought of as interchangeable. In fact, Bitcoin and blockchain are often conflated as being the same thing. But for legal and regulatory purposes, we definitely need to disentangle them. So they're not the same issues. They have different risks. Very simply, as we've discussed before, Bitcoin is a currency and blockchain is the protocol or the infrastructure on which all these things operate on. So in terms of Bitcoin, this is a very controversial subject depending where you are in the world. Lots of divergent opinions from regulators, judges, even policymakers. The policy's approaches completely vary, as we'll see. In some cases, you can have recognition of Bitcoin as a currency, so you can buy and sell things with it. Is it money because it's storing some sort of value? It's an asset class or commodity. So the U.S. has got multiple regulators looking at this, and they all claim simultaneous jurisdiction over Bitcoin, which creates a bit of a nightmare for those trading in Bitcoin and using it. There have been a lot of court cases around this because of that. Another issue is how to apply consumer protection measures and how to apply anti-money laundering measures to Bitcoin. As you'll see, lots of divergent headlines from around the world. Belgian Minister of Justice plans to crack down on Bitcoin activity versus Japan, which is embracing it. But Japan's Bitcoin law goes into effect. Russia eyes legal recognition of Bitcoin in 2008. So, excuse me, lots and lots of divergent regulatory views. There are some papers from the IMF and the World Bank and CPMI which say do this or that with Bitcoin, but again, it's all over the show in terms of how various jurisdictions approach Bitcoin regulation and the legal issues. So in terms of the open legal issues in blockchain, the veracity of the property or asset rights embedded in the blockchain is that issue. The legality of smart contracts. What's the place of contracting using a blockchain? Is it, for example, where the last node issues consensus, or is it the first person to start the process of adding a block? These are all open issues. What's the time of contracting? Is it the first time somebody asked for data to be added, or is it the last node that gave consensus? What's the chain of legal liability if something goes wrong with with something, for example, a blockchain smart contract? Is the programmer liable? Who's liable in this? These are all open questions. It hasn't been tested as yet, so that's why it's open. We all got theories, but it hasn't been really tested. So in terms of regulatory issues, there's varying approaches worldwide. There's some blockchain laws emerging, believe it or not. They attempt to define a blockchain. What's very interesting is a couple of US states have gone ahead and defined blockchains, all in varying ways. In one case, interestingly, Arizona, because they're pro-guns, they put on the blockchain law that no gun registry can ever go on a blockchain, because the idea is people should be free to buy guns and nobody should be able to trace you. So that's one application. It's all emerging. So these blockchain laws that are emerging recognize to some degree smart contracts as real notarized contracts, as if a lawyer had put it together, and also legal recognition of property rights in the blockchain. These are tricky issues because these laws need to integrate into existing electronic transaction laws and e-signature type of laws, and that's not really been done. So these blockchain laws are just emerging out of nowhere with no integration into other electronic type laws, electronic contract type laws, which makes things a bit messy downstream when they test it. Other open issues: how to apply consumer protection measures, how to apply anti-money laundering measures, same Bitcoin. Use of identities registered in one jurisdiction in others. So taking that blockchain, that ID on a blockchain, and can you use it in another jurisdiction or even in another environment in the country without having to go through another set of ID verification. So again, the approaches, the regulatory approaches are all over the show. British government grants millions for blockchain technology research. Reserve Bank of India investigates blockchain for financial applications. Dubai government body sign MOUs to use blockchain and other technologies. China's central bank completes digital currency trial on blockchain. South African Reserve Bank circulates first ever smart contract using private Ethereum blockchain. So what we've got here is an interesting development, is that not only are the central banks and the regulators aware of blockchain, but they're using it themselves to some degree. And because of that, they're actually encouraging others to test blockchain technology. And this is a paradigm called the Sandbox, the regulatory sandbox. And here's a screenshot from the central bank in Malaysia explaining in very simple terms its approach to sandboxing. So you can build almost anything you want in a safe environment with clear boundaries and safeguards, and they may relax some but not all of the existing regulatory rules. And importantly, within the sandbox, the sand's not going to spill over. If there's a problem, the consequence of failure can be contained. So again, the regulators are allowing these new technologies, fintech technologies, to be tested in a limited environment for a limited time. So that usually the permission is got a sunset clause. You says you have to end on July the 24th. That's it. If it works, it works. We might extend, but you have to end it. Again, the existing rules are relaxed. So there's some what's called regulatory forbearance, but not scrapped. They're scrapped altogether because others obviously need to abide by the rules. You're not in the sandbox environment. So a very interesting development. UK FCA is also doing this, and also the Monetary Authority of Singapore. This is again, I won't go through this. This is the proposed Sandbox Criteria, and really the overriding term you need to use to understand is this is all experimentation within a limited environment. So there's lots happening in the blockchain, Bitcoin, distributed ledger technology world, and if you want, we're going to take some questions. Before we do that, we're going to bring up two quick polls. I'd encourage you to participate in them very, very quick. And Jason, our moderator, will bring them up shortly. Jason? While we're waiting for that, I've got a question from Rory McMillan, the double L. He's in Washington, D.C. He's got a question on the various applications, which is most likely to have the largest impact on financial inclusion. Is it the reduction of costs? Well, there's the poll. We just have to hold off on Rory's question. So if you could complete the poll, we'd appreciate that, please. Okay, great. Now we've just got one more poll question. Just wait for that to come up. Okay, I'll just continue reading Rory's question, which again is which application in blockchain technology is likely to have the largest impact? Would it be, for example, the reduction in cross-border remittance costs by cutting out the middleman? Again, if you've got other questions, please send them through. Okay, I think we can close the poll and carry on to the questions. So, to Rory's question about largest impact, I think, quite frankly, it's a bit of a shotgun approach at the moment. Everybody's trying everything with blockchain. But to your point about it's going to cut out costs on remittances, yes. The usual rails are being discarded, if you will, but there are some in-country compliance costs which need to be taken into account. I think IDs are one of the biggest, is going to have the biggest impact. If the other example, which is not blockchain based, is almost the same. If that is taken into account, I'd say IDs is going to certainly have large impact. Within the business-to-business environment, clearing and settlement, definitely, because you make clearing and settlement and interoperability more democratic, and that's already happening with R3. Okay.
Sorry.
Okay. So a question from Samhatin about the large variation in the Bitcoin price. It says it's dropped 30%, 20%. Will such market variation have an impact on the remittance market? If yes, how can Bitcoin be made more trustworthy? So that's a super interesting question, Samhatin. We've all watched the Bitcoin price go through the roof. In fact, it first went through the roof a few years ago because of the Cyprus banking crisis. A lot of Russians stored their money in Cyprus, couldn't get it out because of their financial problems in Cyprus. So they all did a workaround, which is to buy Bitcoin. So Bitcoin price went through the roof. The next phase was through China, signaling that they might accept Bitcoin as a means of payment, legal means of payment. That went through the roof. and then China said no, and it dropped. So there are multitude of reasons, and it goes up and down. It's really headlines and some regulatory intervention which causes the price to fluctuate. So in terms of how it affects the remittance market, that's a very good question. In fact, we had a good discussion with one of the remittance providers using Bitcoin rails, and they, of course, don't want to lose their shirts in terms of Bitcoins, because they need to transfer the Bitcoins. There's a 10-minute lag period between receiving a Bitcoin and information and being able to use it. That's why the split's happening, because Bitcoin processing is very slow. It's 10 transactions per month versus the 17,500, say, for Visa. So there is some arbitrage, there is some sweating that could go on. So what these remittance providers do is as soon as they receive that Bitcoin, they cash it out. So they don't hold into it. The millisecond they get it, it's out of their hands. And some of them are even taking out insurance policies. I think for insurance policies for but in that 10-minute window, things going haywire. Any transaction more than, I think it was $1,500. It costs, I think, $600 a month to insure for that. So that's what these service providers are doing. They're taking out insurance policies. So the net effect for a user is that if you're going through exchange, you're probably better off, because they've got all these tripwires to safeguard your funds, insofar as they themselves are trustworthy. And if you're doing it on a peer-to-peer basis, you're just transferring a Bitcoin, you're likely to, with this volatility, run into a bit of trouble. Okay. From Amol in India. Hi, Amol. Is scalability a problem in blockchain given the slow processing? Can this act as an impediment to access financial products and served in underserviced markets? So that's a great question. All good questions coming through. Scalability is a problem with Bitcoin, not with blockchain. There's very, very, very clever people working on these problems. In fact, they probably all congregated or were last week at Richard Branson's island to discuss all of this. So lots of solutions coming out. I've seen blockchains with 25,000 TPS, transaction per second, processing power being developed. I don't think it's a major issue. So just like mobile money, DFS, and the mobile phone systems use the state of the art when they implementing new systems. That's all they'll do. They'll use the state of the art in terms of the new blockchain technologies that are emerging. Again, we've moved a long way since the original blockchain protocol in 2008. Okay. From Jackie, regarding, excuse me, initial coin offerings. One of the largest ICOs, the DAO, was hacked and led to a hard fork in the Ethereum ledger. Is this a systemic risk, and if so, how can we mitigate it? Thanks again for that question. Yes, these are issues, but again, the communities are aware of this and are fixing these blockchain hacks. Is not to say that they're going to discover everything. Some equally clever people out there with black hats on, trying to undo everything, all the good. So I'd say in terms of systemic risk is that the most proven blockchains are the most usable for now. Ethereum has been fixed, so it's usable. And there are various others. There's Hyperledger and R3's Corda, and these are being bulletproof, if you will. They're kicking the tires as we speak. There's a Fabir. Blockchain offers tremendous savings in transaction costs and time, but will the high initial costs be a deterrent, especially for financial institutions? How do you see this cost coming over time? Well, I'd say that the costs are coming down. there are a lot of DIY blockchain solutions. That ICO paradigm I spoke about, that to an extent is dashboard driven. There are lots of companies that recognize that, look, you know, as I said, this is a prime and not prime numbers. You don't need to be a PhD in blockchain cryptography and private keys and algorithms and blocks to create a blockchain. There are these off-the-shelf solutions which create the ability to have a robust, bulletproof blockchain. And again, the scalability is built in terms of it's distributed across nodes. So the paradigm of you need a lot of processing and redundancies and disaster management, disaster recovery, and a centralized database environment, that kind of is removed. Obviously, it's not removed totally, but those cost reductions are manifest and immediate as soon as you implement some blockchain technology. Here's a question from, I think it's Ari. Are the governments worried about losing control or power from blockchain solutions such as ID or voting systems? Good question. The answer is, the lawyer answer, yes and no. Depends. So in some countries, the more, how should I put this, less democratic inclined countries, there is that concern, so that's why they have very strict rules. But in a lot of countries which recognize the fact that they have existing deficiencies in their systems, for example, they don't even have ID systems that are consistent. Maybe, you know, it's a piece of paper or anything else, or some cards, and it's incompatible. They recognize that they need a consistent, uniform ID system. So they're embracing it. There's, as I said, the central banks are embracing this, and so are the countries. So I gave some examples of where the countries for, so property rights are embracing blockchain technology because they want to democratize and the access to the information and ability to access your own information securely, that they're giving this power to people. So again, it depends. Some countries are more liberal, progressive in blockchain applications than others. Okay. Could you say something, there's Josafa, could you say something about bit license? How can regulations like that improve DLT employment? Well, bit license is, for those who know, is a license issued by New York State to be able to transact in Bitcoin. It came about after a long process. In fact, the first, what they call it, the guy, Bitcoin felon, Bitcoin convict, originated here in New York, and he went to jail for about 15 months for not doing AML on his Bitcoin exchange, not doing proper AML. So don't forget, just because you have Bitcoins, you cash in and cash out, there are some off-rails and on-rails. On-ramps, off-ramps, as I just call it, where you do need AML to be affected correctly according to the regulations, otherwise you get into a bit of trouble. So how can regulations like the bit license improve DLT employment? Well, it needs to be done properly. As I said, there's some US states which have done this, and you know, for the best will in the world, they still define Bitcoin incorrectly. Sorry, blockchain incorrectly. So they defined it, and this is in April this year, long after the immutability paradigm was proven to be incorrect within the blockchain world. They inserted the word immutability in the blockchain definition. So it's an ongoing process to inform and educate regulators, and I think there's good public-private partnerships happening, and there's a lot of collegial meetings happening between regulators, as you can see especially from the Sandbox approach. where the regulators and the industry meet and see how they can improve these things, because regulators want to learn. In fact, I'll say this, we at the Observatory are working on some model regulations that have blockchain impact, so look out for that in sometime in the beginning of 2018 or even sooner. Okay. I think, I know there are a lot of questions, but we're actually at the end of the session, and I want to thank you very much for your participation. Again, please go to the Observatory website, dfsobservatory.com, one word, no hyphens, and check out our database. Also, those on this list will be informed of future webinars that are coming. We'll have some on interoperability, consumer protection, risk management, payments, payment technologies, a whole lot of interesting stuff. And I can say this has been our biggest webinar so far, and far exceeded any others. It's obviously a very, very interesting topic, and we'll see if we can do some follow-ups. Now, just to for those doing the optional quiz, you should have the link in your email box. And if you haven't, just check your spam folder. Sometimes Google, Yahoo, or Hotmail seem to shove it in there. So click on the link. You've got 2 hours from now in which to do it. And if you've been paying close attention to the slides, you'll be able to do the quiz quite easily. They're 10 multiple choice questions. So it's live now for 2 hours, and those who want to can earn the certificate of attendance. I just want to thank the team at Columbia and CITI, Professor Ellie Noam, Jason Buckwright, and Michael Weschler, who put a lot of effort into these webinars and building the systems that make things go smoothly. So with that, I want to thank you. I want to thank you for your participation. I'm sorry we couldn't get to all the questions. There are lots of questions coming through. If you want, send the questions to info@dfsobservatory.com, and we'll try answer them offline. But again, wherever you are in the world, have a great day, great evening, have a great morning, and goodbye from New York.